Assalamualaikum. Today student I have question number 3 of exercise 2.4 and a differential equation in, and this question is and I will today solve it, that how to solve this question by using the exact equation method. We have the students general forms. General forms are partial f by partial x dx plus partial f by partial y dy is equal to 0 and m dx plus n dy is equal to 0. I write its equation number 1, equation number 2 and equation number 3 by comparing equation number 1 and 2 and 3. The coefficients of the dx are equal, that's why m is equal to partial f by partial x is equal to 2xy square minus 3 and n is equal to partial f by partial y. The coefficients of the dy are equal, n is equal to partial f by y, partial y is equal to 2x square y plus 4, and I write its equation number 4 and its equation number 5. So first of all, I have to check the solution. Before solution, I have to check its exactness. So for exactness, there is a condition of exact equation. Partial m by partial y is equal to partial n by partial x. The m and n values I put here. So by putting equation number 4 and 5, m value is partial by partial y of m 2xy square minus 3 is equal to partial by partial x of n 2x square y plus 4. So I will take the derivative, and its derivative with respect to y is 4xy and 0 is equal to its derivative is 4xy and is 0. So it satisfies the exact equation. Partial m by partial y is equal to partial n by partial x. So it is an exact equation. Student, for exactness I will write some method here. Method is m. First of all, I have to write the m. M is partial f by partial x, and I will integrate fx dx, and it will be converted into f. Then I will take the derivative partial f by partial y, and it would be equal to n, and I will find the value of the g of y. That is my roughly method which would be in my mind, and I will obey to this table. So student, consider the m. First of all, I will consider here the m. M is the equation in my this page. Equation number 4 is m. Consider the equation number 4. M is equal to 2xy. M is equal to partial f by partial x is equal to 2xy square minus 2xy square minus 3, and I can write just only without m. I write it 2xy square minus 3 by integrating on both sides. Integration of df, I can convert the partial into d, and into 2xy square minus 3 into dx, and d and integration are cancelled because these are the integral to each other. F is equal to integration with respect to x, 2x square y square by 2 minus 3x plus opposite constant, so g of y. If integration is with respect to x, then there is the constant with respect to y variable. So x square, so f is equal to 2x only x square y square minus 3x plus g of y, and I mentioned it's equation number 6. So now I am coming here because I integrate and then I get the f, and now I will take the derivative. Taking derivative with respect to y, so partial f by partial y is equal to partial by partial y of x square y square minus 3x plus g of y is partial f by partial y is equal to 2x square y minus 0 plus g dash of y. Okay. So, and I know that partial from the equation number 5, partial f by partial y is equal to n. So that is from equation number 5, n is equal to partial f by partial y is equal to 2x square y plus 4. That was, so comparing these two equations, I write here the value of partial f by partial y here, 2x square y plus 4. So I put here the value of partial f by partial y 2x square here in the above equation. 2x square y plus 4 is equal to 2x square y plus g dash of y. I write here, place this value on the left hand side of equal, minus 2x square y is equal to g dash of y. There I noted that this value is cancelled, and g dash of y is equal to g dash of y is equal to only 4. Just like y dash is equal to, I can write here that y dash is equal to dy by derivative of something, I can write it this is. So g dash is partial g of y over partial y is equal to 4. And now I integrate, again integrating on both sides. Dg of y is equal to integration 4 dy. So g of y is equal to 4y plus c, and I mention it's equation number 7. So consider the equation number 6. Equation number 6 is the at value f, and I put here the value of the g of y. Consider the equation number 6. F is equal to x square y square minus 3x plus g of y, and by putting equation number f is equal to x square y square minus 3x plus 4y plus c, g of y is equal to 4y plus c, which is our required general solution. Thanks.